Hey, and welcome to a new devlog about my 2D city builder / resource management game I make with Godot 4 and C#. The main thing I worked on since last time is the procedural generation of resources. For now these resources are stone and wood, but in the future I probably will add some more. I also worked on a few other small things. For example, the player can now control the camera with WASD. And by chance I contributed for the first time a small thing to the official Godot documentation. This time I'll go a bit more into the technical details and my personal struggles I had while developing these features. I hope this is informative and interesting for you. Like always, feedback in the comments is appreciated, and don't forget to subscribe. The raw footage of things I recorded this time is more than 20 hours, so let's get started. I already mentioned it in the intro. The first thing I worked on was to implement camera controls. It's now possible to move the camera with the WASD keys. So later, when we work on the resource generation, we can look around and see everything that was generated. And with that out of the way, we are at the main part of the devlog. The procedural generation of resources. What do all game developers love when it comes to procedural generation? Perlin noise. For people who don't know, with the Perlin noise algorithm, you can generate textures like this. The Perlin noise algorithm also has a lot of parameters to modify the generate noise. For starters, I only think it's important to understand that every pixel represents a value between 0 and 1. Is the pixel white, it's 1, if black, 0. And every grey pixel is something between these two values. If you are more interested, I link a few videos about procedural generation with Perlin noise in the description. For a first test, I generated a Perlin noise and then drew a rectangle for every value in the noise to D array. Next step was to add the ability to generate a new noise and update the visual representation every time I pressed a key. The library Godot used to generate the noise has a cool tool to test and visualize the different noise types and their parameters. I downloaded it and tried a bit out to find good values for the modifiers. Link to the tool is also in the description. After I had found some good values, I started to visualize some potential resource generation. For every value that is lower than a specific threshold in the Perlin noise, I placed a grey square to represent a stone resource. To make the resource generation a bit more natural and organic, I implemented the Cellular Automata algorithm. If you're interested, I recommend these two videos that explain the algorithm. Link to the videos are in the description. By pressing a key, I can execute the algorithm how often I like and see how it affects the resource generation. For now I settled on executing the Cellular Automata algorithm 2 times, and I'm quite happy about the amount and placement of the generated resources. Next task was to improve the visualization of the resources. Instead of simple squares, I want the resource chunks to look a bit more smooth and round at the edges. After trying 2 methods to make the corners of the squares round and getting not the desired result, I started a third attempt, this time with the marching square algorithm. I will again link 2 videos that I recommend if you are interested in this topic. The way I use marching squares is to decide which type of line to draw. Is it the top left corner, or bottom right corner, or is it a straight left line? After a bit of work I got all the 16 cases to work, and now the resources were visualized by these outlines with round corners. Instead of only outlines, I now want to fill out the whole area of the respawned resources. I plan to just replace the draw cycle arch method I used to draw the outlines with the draw polygon method, but I had problems making the example code from the official Godot documentation work, and after way too much time I found out what the problem was and fixed it. I then also fixed the issue in the official documentation, created a pull request on GitHub, and after some time the pull request got approved and merged. For me it was the first time contributing to an open source project. And even though it's not much, I'm very happy that next time someone wants to try the example code, they don't have to struggle like I did. Now back to the visualization of the resources. After I got the draw polygon method working, it was really fast obvious to me that the current approach was again not viable. After only replacing one of the 16 possible cases, the frames per second dropped significantly and the game was laggy. So yeah. I needed again a new idea for how to solve the resource visualization. Well, the next idea I had was to try tile maps, maybe this will work. I never had used a tile map in any of my games. The only thing I knew was that the tile map / tileset system in Godot 4 was completely rewritten. so I first spent some time reading about tilemaps, tilesets and the new system in Godot 4. As a first test I used a tileset from Kenny, but I quickly understood that it's not fitting for my purpose, so I created my own tileset, with all the possible combinations that can occur in the marching square algorithm. After struggling for some time, I found a problem why the tiles were not aligning well. The problem was not the coding that I thought the whole time, but instead some tiles I created were wrong. I fixed the wrong tiles and now the visualization of the stone resource is looking like I wanted. Now it's time to add a new building that can extract the stone from the generated resource chunks, the mine. After being constructed, the mine collects stone from stone chunks in its range. Stone chunks that a mine extracts from will shrink until fully depleted. To implement this behavior, I first need to get a list of all the stone chunks that are in the range of the mine. It sounds pretty simple, but to my misery I had to learn that it's not as easy as I thought. So the main problem I had is when using the body shape enter signal, I am not able to get the information which stone chunk has entered the range. The object that the signal is given is not a specific tile, but instead the whole tile map. So I know that some stone chunk is in range, but not which one of all the stone chunks that exist on the tile map. I searched a long time all over the internet for a solution for my problem. And then finally I found under an old GitHub issue that someone opened some time ago this example of how to get the tilemap coordinates of the specific tile that entered the range. But when I wanted to test it, I found out that this method no longer exists. Having still a little bit of hope that there needs to be the good cause why this method got removed, I searched in the GitHub repository for the commit that removed this method. And as I had hoped, there really is a good reason why it was removed. Thanks to this good commit message, I now know that the new Godot 4 tilemap has a method that solves my problem. And yeah, if I only had the idea to check the tilemap documentation from the beginning, I wouldn't have had to spend hours of my life trying to find it. So now I have the list of all the stone tiles that are in the area of the mine. The mine will choose one of them every few seconds and decrease the life of the resource chunk by 1, in return for 1 stone. When the life of the chunk is at 0, it's fully depleted and will vanish. When this vanishing happens, right now the whole tilemap will be updated, and the game has a small lag because of it. To make it more performant, I created a method that will only update the tile that is vanishing and its 8 neighbor tiles. And voila, the mine works as I planned. I now fixed 2 things that were bothering me the whole time. When moving the camera with the keyboard, the UI now also follows the camera and does not stay static in the game world. And second, when in build mode, the node that is following the mouse is also affected by the camera movement. And now to the last part of this devlog, that will also be a lot quicker than the rest. I refactored the resource generation to support multiple resources and not only stone. After I got it working, I added a second type of procedural generated resource, wood. I then repurposed the tree node to the lumberjack node. The lumberjack works like the mine, but as the name suggests, it cuts trees and produces wood, and not stone. Because the tree node is gone, there is no way to get wood at the start of the game. To fix that temporarily, the player now gets at the start of the game a storage with a few resources to get started with building nodes. And that's it for this devlog. Thank you for watching. A like and feedback in the comments is appreciated, and I hope to see you in the next video. Bye!